Assalamu alaikum warahmatullahi wabarakatuh. So today our first class will be based on the general revision, that is the solution to mock exam that we did last time. So don't forget that your section B is divided into two parts, that is part 1 and part 2. So we are going to start our revision from part 1, and you know that in part 1 consists of 10 questions where you are asked to just answer 5 questions, and each question carries a equal mark, that is 3 marks for each question, giving a total of 15 marks for part 1. Now, so the instruction says you answer any 5 questions. So we are going to start from question 1. And what is question 1? So in order to make it easy for you, we just implore you to have your answer booklet beside you so that you'll be going through it as I'm giving you the solution. Now, question 1 states that a stone is projected vertically upward with a speed of 25 meters per second from the top of the tower of height 65 meters. Full stop. Neglecting air resistance, determine the maximum height it reached from the ground. I repeat, a stone is projected vertically upward with a speed of 25 meters per second from the top of the tower of height 65 meters. Neglecting air resistance, determine the maximum height it reached from the ground. So we are given accelerated to gravity G to be 10 meters per second per second. Now, what are we given in the question? So we are given the initial velocity to be 25 meters per second. Our final velocity is 0. Now, before you lay your hand on this, the first thing you need to do is to make sure that you understand what the question is trying to say. You are having a tower that is of height 65 meters. You can do the demonstration on the board. The height of the tower is 65 meters. But from the top of the tower, an object was thrown vertically upward, cover another height represented by this small letter H. But the question is not asking us to calculate the height attained by this object from the height of the tower. The question is asking us to calculate the total height from the ground. You can see, from the ground to the maximum height reached by the object. So that's why I denoted this maximum height to be capital letter H. So from the question, the parameters we are given are initial speed 25 meters per second, final velocity to be 0. We are given G to be 10 meters per second. Now, since the body was thrown vertically upward, so we use one of our equations of motion, and the best equation of motion that suits this particular question is V squared equal U squared minus 2GH. So substitute, the first thing we need to calculate is to calculate our small h. After obtaining our small h, so to calculate our capital H will be very, very easy for us. Since you know the height of the tower to what? 65 meters. So from here, you can easily make our h the solid formula. So my V is 0, so I have 0 squared. My U is 25 squared minus 2 times 10 times h. So from here now, h will be equal to 31.25 meters. So this is the height of the object, the height reached from the object from the top of the tower to this point. Now, therefore, the total or maximum height from the ground will be h equals 1h plus 65 meters. That is 31.25 plus 60 plus 65. So our final answer for this will be 96.25 meters. So that is the solution to the first question. That is the solution to the first question. Now let's go to question 2. Let's go to question 2. Now, before we go to question 2, so my remarks based on question 1 is that majority of you attempted the question, but you obtain the solution, the answer to that small h. So next time when you are given such question, you make sure that you add that small letter a you've calculated for and the height of the tower, so you add the two together. Now question 2. A force of 60 Newton is applied at the end of a wire fixed at one end to produce an extension of 0.03 meters. Full stop. If the original length and diameter of the wire are 5.2 meter and 2.1 millimeters respectively, calculate the A. stress on the wire, B. strain in the wire. We are asked to calculate the stress and strain in the wire. So, like I always told you people, that anytime you are calculating for anything in physics, so your calculations are always based on 3 different steps. Just 3 steps. The first step is that of your correct formula. I think you write the correct formula. Once you figure the correct formula, then you substitute. Then the final step is your final answer together with the unit. Those are those 3 main or major steps. So let's look at this in question 2. What are we given in the question? We are given a force, applied force, to be equal to 60 Newton. We are given the original length of the wire to be 5.2 meters. Then we are given the diameter of the wire to be 2.1 millimeters. So you try to convert, because this diameter does not have a standard, it's not a standard unit. So you convert this one to meter, and by converting this one to meter, you're going to have 2.1 exponential minus 3 meters. So from the definition of stress, so the first one, which is H, stress. Our stress is calculated using force over cross-sectional area. And don't forget our area, because the area is not given in the equation. So we try to look for the value of area. So we can use pi d squared over 4 to calculate our area, where pi is given to be either 3.142 or 22/7. So you take it. Now, substituting all this parameter into this, we have stress equal 60 over area, that is 3.142 times d. Our d diameter is 2.1 exponential minus 3, then over 4. If you use your calculator to find the final answer to this, so we obtain 17.32 exponential 6 Newton per meter. So make sure, like I said, 3 major steps are very, very important when you are solving any physics question. The first one is your correct formula. Second step is substitution. Then the last step is final answer together with the unit. And you can see this unit, negative per meter square, we obtain it from the expression we have here, that is for the unit of what is negative, while that of area is meter square. Now B, that is strain. So strain is defined as extension over original length. So we have, so extension equal, from the equation we are given extension to be 0.03 meter. Then we substitute 0.03 over original length. The original length is 5.2 meter, and this one is meter. So meter and meter will cancel that. So our final answer for the strain is 0.0058. So strain has no unit because the extension is a meter and the original length is also a meter. So the two units are going to cancel out. Now, and then that is that on question 2. On question 2. So my remarks on this is that most of you got the question, this particular question, you got it right. Nearly everybody. Just few students among you missed the question. So let's go to question 3. Okay, how many please? So question 3 says that explain why water has a concave meniscus and mercury has a convex meniscus. Explain why water has a concave meniscus and mercury has a convex meniscus. I will refer you back to your SS1 note where we treated two different types of forces like cohesive and adhesive force. So I think I still recollect. Now the solution to this particular question number 3 is that the reason why water has a concave meniscus is that the force of adhesion holding the water molecules and the glass molecules together is stronger than the cohesive force holding the water molecules together. And the reason why mercury has a convex meniscus is that the cohesive force holding the mercury molecules together is stronger than the adhesive force holding the mercury and then the glass molecules together. As simple as that. So question number 4. Question 4. Explain what is meant by anions. That is 4A. And 4B. Draw and label a photometer. Draw and label a photometer. So the answer to question 4A is that what is anions? Don't forget, you have two types of ions. You have the anions, you have the cations. The same way we have two types of electrodes. We have the cathode, we have the anode. And in the process of electrolysis, we have that electron dissociate into positive and negative ions. So the negative ions are the anions, while the positive ions are the cations. Now in electrolysis, during that process, the anions are the negative ions that move or drift towards the anode, that is the positive electrode during electrolysis. That is answer to question 4A. So let's go to question 4B, where we ask to draw and label a photometer. So question 4B asks us to draw typical diagram, well labeled diagram of a photometer. Now, this is a typical diagram of a photometer, and the photometer is just a device on an instrument used in the study of electrolysis. So it consists of two electrodes, that is the cathode and anode. So the liquid inside it, called the electrolyte, that is the liquid that allows the current to pass through it. So we have the anode and then we have the cathode. Now here we have the ammeter to indicate or to measure the amount of current that is flowing through the circuit. So we have the source of potential difference, that is the EMF regulated by E. Then we have the variable that is called the rheostat. Then we have the key that you can use to switch on or switch off the circuit. Now my remarks on this particular question is that some of you don't want to draw this, so you went ahead and drew a diagram of voltmeter, in which photometer and voltmeter, they are just two different things. A voltmeter is an instrument used for measuring the amount of EMF or potential difference in a circuit, but a voltmeter is used in the process of electrolysis. So don't confuse the two together. I think you are getting it. Now let's move on to question 5. Question number 5. Explain why sound wave cannot be plane polarized. Explain why sound wave cannot be plane polarized. The simple answer and straightforward answer to that is that, don't forget, we have the properties of waves. We have the properties of reflection, refraction, diffraction, interference, and polarization. Now, we also have two types of waves, that is transverse and longitudinal wave. All transverse waves undergo all these 5 properties of wave, but longitudinal wave undergo 4, with the exception of polarization. And since sound wave is a longitudinal wave, then it cannot be plane polarized. So the correct answer to that question is that sound wave cannot be plane polarized because it is a longitudinal wave. Only transverse wave undergo all the 5 features, all 5 properties of including polarization. So question 6. So this question consists of 2 questions. We have A and B. So 6A says that on what principle does lighting in a fluorescent tube operate? On what principle does lighting in a fluorescent tube operate? From this particular topic, the conduction of electricity in gas. So the principle in which the light in the fluorescent tube operates is that it operates on the principle that under low pressure and high potential difference. That's just the answer. Low pressure and high potential, that is for gas in a discharge tube to conduct electricity. So such gas must be under low pressure and high potential difference. So question B states that state 2 factors which determine the color of light produced in a fluorescent tube. State 2 factors which determine the color of light produced in a fluorescent tube. So the 2 factors are the nature of gas in the fluorescent tube. Don't forget, fluorescent is an example of discharge tube. Now, the nature of gas in that fluorescent tube, and 2, the type of coating material of the fluorescent tube. The type of coating material and the type of gas. So those are the 2 factors which determine the color of light produced in a discharge of fluorescent tube. Question 7. Question 7. An electron moves with a speed of 2.5 exponential 7 meter per second in an orbit in a uniform magnetic field of 1.4 exponential minus 2 Tesla. Full stop. Calculate the radius of the orbit. Open bracket. We are given mass of the electron to be 9.1 exponential minus 31 kg. We are given charge on an electron to be 1.61 exponential minus 19 coulomb. So, from the question we are given, from this question, we are going to write out the parameters we are given in the question so that we know the best formula that we are going to apply. That is question 7. So we are given in the question the speed, that is, we are given the velocity v to be 2.5 exponential 7 meter per second, 2.5 exponential 7 meter per second, and then we are given magnetic field, that is B, magnetic field B equal 1.4 exponential minus 2 Tesla. Then we are also given the radius. The radius, I think the electron is moving around to be, okay, we have to calculate the radius. Sorry, we have to calculate the radius. So we are also given the mass of the electron, that is M subscript E. This E stands for electron, to be 9.1 exponential minus 31 kg. Then lastly we are given the charge on the electron, that is Q. The charge Q equal 1.61 exponential minus 19 coulombs. Minus 19 coulombs. At times, take note of one thing, please. At times, this charge Q, at times you can use Q to represent our charge, or we use small letter E. Or we use small letter E. That small letter E is called electronic charge. Electronic charge. You take note. So both Q and E mean the same thing. Now, how do we solve this? How do we solve this? Say we are given the velocity, we are given the magnetic field, we are looking for the radius of the orbit of the fast moving electron, we are given the mass of the electron, then we are given the charge on the electron. Then we apply that. The force making that electron to revolve around in its orbit is given, that is centripetal force, mv squared over r. Because that electron is moving around in the presence of magnetic field, so there is also the presence, there is tendency of the effect of the magnetic force acting on that fast moving electron. Then we also have, this is centripetal force. Then we have magnetic force equal QVB. Now these two forces must be equal, that is Fc equal Fm. Then I can equate this and this, so I have mv squared over r equal QVB. Then I will make my r the formula. My r is going to be mv squared over QVB. Substituting for all these parameters, we have our r to be equal to 0.01 meter. 0.01 meter. 0.01 meter. Now let's move on to next question. That's question 8. Question 8. So we still have this question 8 still of two different questions. That is, we have question 8a and question 8b. Question 8a and question 8b. So question 8a states that what is an intrinsic semiconductor? What is an intrinsic semiconductor? And B, distinguish between the p-type and n-type semiconductors. So we've done all this. Now, what's an intrinsic semiconductor? That's 8a. Intrinsic semiconductor, they are pure semiconductor in which they have not been doped with any impurities. So we call them pure semiconductor that have not been doped, that have not been mixed up with any other impurities. So that is intrinsic semiconductor. Now, B is in between the p-type and n-type semiconductors. The p-type semiconductors, they are obtained by doping intrinsic semiconductor with trivalent impurities. P-type semiconductors are semiconductors in which the intrinsic semiconductor, that is the pure semiconductor, are being doped with trivalent impurity. Or if you know, you can still define p-type semiconductor as a pure exterior semiconductor in pure semiconductor which have more number of holes than electrons. It will be 2. What n-type semiconductor? They are semiconductors that in which the intrinsic of pure semiconductor have been doped with pentavalent. Or in other words, we can still define our n-type semiconductor as a semiconductor in which have more number of electrons than holes. So that's the answer to question 8. Now question 9. Question 9. What does the acronym LASER stand for? What does the acronym LASER stand for? The acronym LASER stand for light amplification by stimulation emission of radiation. LASER stand for L stand for light, A stand for amplification, by S stand for stimulation, of R stand for radiation. So light amplification by stimulation of emission of radiation. Stimulation of emission. E stand for emission and R stand for radiation. By stimulation emission of radiation. So laser is just a way of producing a monochromatic light. And what's monochromatic light? Monochromatic light is the light that has a single wavelength, or they are light of a single color rather. They are single colors light, like red light, blue light, green light, and the rest. And then we have B, question 9B. Give 2 applications of laser. Give 2 applications of laser. Give 2 applications of laser. So laser can be used. One of the applications of laser is used in medical field to perform laser surgery. It's also used in printing system or in printing devices like photocopying machine. So lastly, the last question, that's question 10. So we are given a particular diagram. We are given a particular diagram here. That question 10. Question 10. So we are given a diagram here. We are given a diagram here. So we are given a diagram, and the question underneath is that from the diagram above, will the ray bend downward or upward? Question mark. From the diagram above, will the ray bend downward or upward? Question mark. So the next question is that explain. That is, you explain your answer whether the ray is going to bend downward or upward. Now, before you can answer this question, you must know the main characteristics or properties of cathode ray. So cathode ray, they are fast moving electrons. If you check your notes, you're going to see it there. I know you have it in your notes. Now, they are fast moving electrons. And for us to call cathode ray fast moving electrons, it means that they possess negative charge. They possess what? Negative, or they are negatively charged. So this is electron gun, which emits cathode ray. Then the emission of cathode ray is now placed in a magnetic field. That is, we having magnet, having North Pole and South Pole. Now, don't forget, so if you say the cathode ray has electron identity, that is, it is negatively charged. We are given a bar magnet having North and South Pole, and the North Pole of the bar magnet behave like a positive charge, while the South Pole of the magnet behave like a negative charge. So, before you answer the question, you must first get all these things right. The cathode ray has electron identity; it is negatively charged, E minus. The North Pole of the bar magnet behave like a positively charged particle, while the South Pole of this magnet behave like negatively charged terminal. So that's why I indicated this way to be plus, positive charge, negative charge, and the electron is there. Then, from the fundamental law of electricity, this is positive, this is negative charge. What type of reaction is going to take place? Is it going to be repulsive or attractive? It is positive and negative. So from that law, we understand that like charges repel each other, where unlike charges attract each other. Since unlike charges or two opposite charges attract each other, there is going to be a kind of attraction between this cathode ray and the north pole of this magnet. And in that case, the ray is going to bend downward, trying to get attracted to this north pole of the magnet. So in short, the answer to the first part of the question is that the ray is going to bend downward. But let's assume that you are given a bar magnet having south here, and this one is having north. In this case, this is going to be positive, this is going to be negative, and south and electron, they are negative. In this case, the cathode ray and then the south pole of the magnet are going to repel each other. And you understand? And when they repel each other, the ray is going to move upward. I think I've explained the other aspect. So the correct answer is that the cathode ray is going to bend downward. And the explanation is that because the cathode is negatively charged and the north is positively charged, they are going to attract each other. They are making the cathode to bend towards the north pole of the magnet. So here we come to the end of the first part, that is part 1 of the theory part of your last term mock examination. So our next class will be based on the part 2 of that section B. Part 2 of that section B. In case you might have any question you want to ask me, you can reach me on 070-6593-3261, or you email me at salakonaji@gmail.com. This is my phone number. You can also WhatsApp me or text me on my WhatsApp page, or you send any question to this email address. Next time I come your way, I remain your man, Salako Najin. Bye for now.